2. Number 6, it said, figure out the volume of this pyramid laying down, and they say this is x, so let's call this the axis dx, and this can be y and z, or it could be the other way, doesn't really matter. And they want to do this, so the thickness of the slice is dx. We've got a picture of it. The area is going to be 1/2 base times the height. That's the area of a triangle. We're going to integrate it. The x is going to go from 0 to 8. So now we got to get the base, which would be this side, in terms of x. This is a z and this is the x. We've got a line that's going like this. If this is the x-axis and this is the z-axis, we would write z. This is a z here. So the base is z. And z would be equal to, well, it has a z-intercept of 6 and a slope of, it goes from 6 down to 0 as we go out 8. So minus 6 over 8. Down 6 over 8. X. So that's z, the base. So we got the integral from 0 to 8, 1/2 the base minus 3/4 x plus 6 times the height. The height would be this. So that's in the y direction, so it's y. So we have to find the equation for y. Well, y would equal, it has a y-intercept of 4. It has a slope of down 4 over 8, so that's a minus 1/2. Down 4, out 8. Because it's going in the positive 8x direction, x. So we have minus 1/2 x plus 4. Okay, now we're ready to integrate, except that those are multiplied, so we better multiply them. So we got 1/2 0 to 8 of negative 3/4 x times negative 1/2 x. That's plus 3/8 x squared. Minus 3/4 x times 4 is minus 3x. And 6 times minus 1/2 is minus 3x. That's minus 6x. And then plus 24 dx. So we get, this would go to the third, divide by 3. That would make it 1/8 x to the third. This would be minus 3x squared, because it puts a 2 under the 6, which is 3. And this would go to plus 24x, evaluated from 0 to 8. The 0 is not going to do anything. And so we get 1/8 of 8 times 8 times 8. One of the 8's cancel, and I get 64. 8 times 64 times 3. 64 times plus 64 is 128. 3 times 4 is 12. Carry the 1. 18, 19. 192 I get. And then 24 times 8. 24 times 4 is 96. So 192. Then I put in 0. And so these cancel, and I get half of 64, which is 32. Let's see if that's right. This is basically a pyramid, so you take the area of the base, which is 4 times 6, 24, cut it in half, that's 12, times the height, 8, and then a pyramid, you do 1/3. So 3 goes into 24, 8 times 8 is 64, divided by 2, 32. So now if we do it on this one, so just like we had before, it should be this times a half, B times C times a half times A times 1/3. So it should be 1/6 of ABC. But we're going to do the integral from 0 to A of 1/2 the base. And so now it's 1/2 the base times the height, D, and we'll call this the x direction. And if this is the z-axis and this is the x-axis, z has a z-intercept of b and a slope of minus b over a x. And y, if this is the y-axis, has a y-intercept of c and a slope of minus c over a x. So we get 1/2 integral from 0 to a of base, the z, minus b over ax plus b times the height, minus c over ax plus c. So we get 1/2 integral from 0 to a of this times this is plus bc over a squared x squared. Then we get this times that is minus bc over ax. This times this is minus bc over ax, so that's 2 of these, plus bc dx. And the integral, we got 1/2. Integral of this would be bc over a squared x to the third over 3 minus 2bc over a x to the second over 2 plus bcx, evaluated from 0 to a. So we get 1/2 a cubed over a squared is just a. When I put a in here, I get a cubed. A squared cancels 2 of them, so I got abc over 3 minus 2's cancel, and I got a squared over a, which just is abc, because one of the a's cancel, and I get abc. And then I get plus, I put a in there, and I get abc. And when I put 0 into all these, I get 0. So I get that and that cancel, and I get ABC over 3 times a half ABC over 3 times a half. Same thing. 1/6 ABC. Lots of letters. Not really that tricky. Okay. 8. The base is a circle of radius 1. So I'll call that the x, and this is the y, and this is the bottom. This is a 3D something that has, if I cut it perpendicular to the x-axis, a plane straight up perpendicular, that what I get when I cut this shape is equilateral triangles. So this distance up and back down. So I'll draw it like this, but it's supposed to be coming out of the paper, up in the direction. So here it comes up and back down and across. And then they get smaller here. They're up and down. So it's got a kind of a rib here. Okay? So they're all triangles. The thickness, dx. I got a picture, I got a thickness, and my limits, what's going to be symmetric, so I'm going to go from 0 to 1, and they're triangles, so it's 1/2 base times height. And these are equilateral triangles that look like this. So whatever this side is, the height would be there. So this is, if that's a side and that's a side and that's a side, this piece right there is 1/2 of a side. And this is a square root of 3 over 2 times a side. 2, 1 square root of 3, 1/2 square root of 3 over 2. You know this is a half, that's a full side, so you can go s squared minus 1/2 s squared, which would be 1/4 s squared, is this side, the height. Squared, 1 minus 1/4 is 3/4 s squared is the height squared. And then take the square root, and I get square root of 3 over 2 of the side is the height. So, but what is a side here? Well, if I use this one, that is y. So this is y. So this is 2y, and this is square root of 3y. So the height straight up to this is square root of 3y, and the base is 2y. So I have from 0 to 1 1/2 times the base, which is 2y's, times the height, which is square root of 3y, dx. Oh. All right, let's clean this up. The halves cancel. The square root of 3 could come out, so I got the square root of 3 integral from 0 to 1 of y squared dx. Oh, but I needed an x. But now I just got to get y squared. So that's 1 minus x squared. Oh, that's not so bad. Square root of 3 integral from 0 to 1 of 1 minus x squared. Oh, and what did I forget to do? We're only doing half of it, so we got to double the answer. So I should have put in here 2. I should have put a 2. I should have put a 2. So this should have a 2 squared. It's a 3 there. dx. Now I can integrate. 2 square root of 3. 1 integrated is x. that becomes x to the third over 3, evaluated from 0 to 1. So I get 2 square root of 3 times 1 minus 1/3 minus, putting zeros in, I get 0. So 2/3 times this, so that's 4/3 square root of 3. Okay, 9. We still, same base, little different cross section when I slice it this way. This time I get triangles where the base is same as the height. Well, since we've done this already once, we got a pretty good idea here. It's going to be 2 of them going from here to here, or from here to here, I should say. Integral from 0 to 1 of 1/2 base times the height dx, which is, these will cancel, so it's just integral from 0 to 1. The base is 2y, because that's y, and the height is the same. So because they said it was the base and the height are the same, times 2y. Okay, so we have integral from 0 to 1 of 4y squared dx. Okay, so we got to get x in here. So we got 4 integral from 0 to 1 of y squared is 1 minus x squared. Okay, so we got 4. 1 integrated is x. X squared integrated is x to the third over 3. Evaluated from 0 to 1. So we get 4, 1 minus 1/3, which minus 0. So that's 2/3 times 4 is 8/3. These are a little bit higher because the height is the same as across here, where the height is not the same there, it's shorter. So we should have gotten a little bit bigger number, and I think that is a little bit bigger. Instead of 4/3 times 2, 8/3, it's times 1.7, which is a little bit less. Okay, 21. So we have a pipe running into the pipe, and we're supposed to calculate the area of the intersection, which is kind of this weird shaped thing that's rounded like the pipes are here, and in there, and then there, and back there. But what's nice is when you slice it like this, the height of the water, it could be in here, you get a square. And the square, if they put y this direction, y is this direction, so if we put x this direction or whatever, it would be whatever this is. Let's just call that x. So it's x and x. It's 2x by 2x by 2x. So the thickness of this is in the y direction, so the thickness is dy. The integral would be from, well, it's symmetric, so we can go from 0 to the top of the pipe, r. And the area would be 2x times 2x, 4x squared. Okay? 2x times 2x, 4x squared. And x is this, and y is here, so it's dy. So we got to get this in terms of y. Well, you can see the triangle right here. x squared plus y squared equals r squared. So we got to get the x squared out and get y squared in. So x squared is equal to r squared minus y squared. R is a constant, it's the radius of the pipe, and so that's pretty simple. To integrate that, it's going to be r squared y, a constant, like 3 integrated is 3y. R squared integrated is r squared y, and this is minus y to the third over 3, evaluated from 0 to r. So we get 4. Oh, I said there was symmetry, and we were only going to do it from 0 to r, so I got to double this. I almost forgot to double it. So double it. So double it. 2 times 4. This is evaluated, putting an r in there. We get r to the third minus r to the third over 3. Putting in 0 minus 0. So I got 8 times r to the third minus a third of it is 2/3 r to the third. So that's 16/3 r to the third. The gorillas are gathering around this grassy clearing that has water in it. And maybe there's trees outside that. Anyway, from the center out, the population decreases, and you can put in different numbers for R, and you can see that it'll decrease as you move out. You can plot this on the calculator, and you can see that it decreases as you move out. Let's do that. 52 parenthesis 1 plus x squared, close parenthesis, to the -2. And let's go zoom 6. Dense real close and gets less dense as you move out. I could go a little higher here. Looks like it might get up to 50, so let's put 40 as the max. Graph gets up to 52, it looks like. But you get the idea? All right. What we do when we got these is we want to take the how many people per square, number of gorillas per square kilometer, times the area of a ring around it. So we got the inner goal. We're going to go out to 5 kilometers from the center to 5 kilometers out. The length of the ring, the thickness of the ring is a small amount of r. And the length of this rectangle, you're thinking about this ring as being a rectangle. That's dr, and it's the distance around a circle, which is circumference, 2 pi r. 2 pi r dr, that would be the area, times the population on that area. So times 52 times 1 minus r squared to the -2. And you're looking at it and saying, I don't like this, but that's all we're doing. The area of the ring times the population per square unit of area to get the total population. All right, the 52, the 2, and the pi all come out. So that's 1/4 pi. Integral from 0 to 5 of 1 minus r squared 1 minus r squared to the minus 2 dr. Oh, and there's a r in there. And that's good because we're going to let u be the stuff inside here. So u equals 1 minus r squared. Du is negative 2r dr. So we're going to replace dr with du over negative 2r. And that r is going to cancel that r. So we're going to have 1/4 pi integral from something to something because we're now changing to u. We have an r, we have u to the minus 2, and dr is du over negative 2r. r's cancel, the negative 2 can go out there. So we're just integrating u to the negative 2. We'll add 1 to the power and divide by that what we get. So we got 104 divided by 2 is negative 52 pi. Integral, we're integrating. So that'd be u to the minus 1 over minus 1, evaluated from don't know to don't know, which becomes the negative 1 and the negative there become 52 pi of u to the minus 1, which is 1 over u, and u was 1 minus r squared, evaluated from, now I'm back into r, so it's 0 to 5. So I put 5 in there, 1 minus, was that minus or plus in this? It was plus. Whoop. That was plus. So this should have been plus. So that should have been plus. So that should have been plus. That should have been plus. That should have been plus. Oh my goodness, oh my goodness, oh my goodness. That should be plus. And that should be a minus. So now we're minus here because of that minus. And that's plus. So I put 5 in there. I get 25 plus 1, 26. So I get minus 52 pi times 126 minus, put 0 in there, and I get 1 plus 0 is 1. 1 over 1 is 1. Okay, so 1 over 26 minus 1 is minus 25 over 26, because that's 26, 26 minus 26, 26 plus 1 is minus 25, and that's minus 52 pi. The minus cancels. 26 goes into 52. 2 times 25 is 50 pi. Pi is about 3, so there's about 150 gorillas around there. A little over that. Whatever 50 pi is. Gorillas. Sorry, it was off the screen there a little bit. Okay, circular plate with the density. We got a density, so we got to find the area of this circular plate. And the density at the center, see, as r goes to 0, 4 over something really small gets really big. So the density gets really heavy in the middle and gets less dense as you move out. It's kind of like it's a black hole, infinitely dense in the middle. Black holes are really, really dense, but we don't care. Goes out to a radius of 2. We do the same thing as we did before. We find out the area of a ring out here times the density in that ring. So we're going to go from 0 to 2. The the thickness of this ring is dr, some change in r, and it's 2 pi r is how far around times the height, dr times 2 pi r, that's the area of this ring, times the density of that ring, 4 over r grams per centimeter. So the density times that, and the r's cancel, the 4 comes out, and we have 8 pi integral from 0 to 2 of dr. 1 dr. Integral of 1 is just r. So we got 8 pi r evaluated from 0 to 2, which is 16 pi minus 0. So it's just 16 pi grams. And the centimeters squared are gone because we took it times area, centimeters squared, and times something that's per centimeter squared, and we get just the grams. 37. Got a solid rod with another rod inside, and the velocity is this. And the book says the velocity, the quantity flowing in the pipe is the integral from center out of the area of the ring to pi r times the velocity at that radius. And the velocity is given by this, so it's 0.5 times r minus 1 times 3 minus r. Centimeters per second, the velocity times the area of the ring, dr, going from 1 centimeter to 3. I believe that's what it was. I think it's supposed to be the area. I better grab my book real quick and check that. Six two. The flow rate. You can see it here. The flow rate is 2 pi r, the area of the ring, times the velocity, and the area of the ring is dr thick or wide and 2 pi r long rectangle. Okay. So we have 2 pi r dr, the area of the ring, times the flow rate, the velocity at the different places on that ring. So we get the 0.5 can come out times the 2. That makes it just pi, 1 to 3. We're not going to do it inside the solid pipe, the rod inside. It's just from outside of it to where we go, from 1 to 3. And we have, if we multiply this and then take it times that, so we got, let's do this, 3r minus r squared minus 3 plus r. So that's minus r squared plus 4r minus 3 all times r. So we got minus r to the third plus 4r squared minus 3r dr. We can now integrate, and we're going to get, pull it back here, we're going to get pi minus r to the fourth over 4 plus 4/3 r to the third minus 3 over 2r squared, evaluated from 1 to 3. So we put in the 3 and we get pi. 3 to the fourth is 81 fourths. 3 to the third, one of the 3's cancel, so it's just 9 times 4 is plus 36. 9 27 halves. Minus, putting 1 in here, we get a minus 1/4 plus 4/3 minus 3 halves. So we got pi 80 minus 81 plus 1/4 is 84, which is 20, minus plus 36, and so we got plus 3 halves minus 27 halves, that's 24 halves, minus 24 halves, which is minus 12. So we got minus 32 plus 36 is 4 pi. Cubic centimeters per second. Cubic centimeters per second. This is velocity. It's meters per second. It works out. Times your area. Supposed to give the volume. Anyway. Oh, yes, it gives you cubic centimeters per second. That's the flow rate. How much volume per second? Volumes per second, flow rate. All right. Okay. Now we're just finding average. This is going to be easier. X to the third, we know it looks like this. From 0 to 4, it goes from height of 0 to a height of 4 cubed is 64. It goes from 0 to 64, so the average height is somewhere around 32, although it hangs around lower here for longer, then shoots up. So it's going to be lower than 32 for the average height. So we just find the area under this curve and then divide it by the width to figure out how high a rectangle would be to make this. So you take take the width, which is 0 to 4, or 4, and you're going to divide the area, and the area would be the integral from 0 to 4 of x to the third dx. You take the area divided by the width, 0 to 4, and you get the height. So this is 1/4 x to the fourth over 4, evaluated from 0 to 4. So if I put 4 in there, I get 4 times, divided by 2/4, so that's just 4 twice. 4 times 4 is 16. Put in 0, I get nothing. Average height is 16. Okay? Because the area is 4 times that, 64, under this curve. It gets to a height of 64, but it's 4 wide, but the area turns out to be 64 too. And so you divide it by 4, and you get a average height of 16. Now we're going to do this, but we have a known width, but we have an unknown curve. So it's going to depend on what the constant is, what the average height is. So there should be an n in our answer. So we find the area from -1 to 1 of e to the negative nx dx. And then we're going to divide it by the width of the interval, which is 2. So I'm going to write a half. 1 minus a minus 1 is 2. So we've got to integrate this and then divide by 2. Well, integral of e to something is e to the something. And integrating, it's divided by the whatever the derivative of that is, which is negative n. We're going to evaluate from -1 to 1. So we put 1 in here, and we get 1/2, excuse me, e to the negative n over negative n minus, we put a -1 there, and we get e to the n over negative n. And we get this to simplify to 1/2. These are both over negative n. So we've got negative n e to the negative n minus e to the n. E to the negative n is 1 over e to the n. So this is 1 over e to the n minus e to the n. And the negative could make this negative and that positive, so we can write this as 1 over 2n e to the n minus 1 over e to the n. This would have been fine. This would have been fine. Any of those. Oops, I kind of went off the screen again. Sorry. I'm drifting. Okay. Temperature in Walla Walla in July. How, and that's time, and this is the temperature. Why would it be something like this? Well, this is kind of the average, and then it's fluctuating above and below that. What's the period on this? Well, if you remember your 154, the period is the normal period of sine 2 pi divided by what's times the variable, which is pi over 18. So the pi's cancel. If you invert and multiply, you get 36. So this one has a period of 36, which is about a whole month long. T, 36 days. T is days, and so this is 36 days. And what's this? Well, that would be 2 pi divided by pi over 2, which is, the pi's cancel, is about 4 days. So we have a period of 4 days and a period of 36 days. Explain. Well, I'm struggling to explain that. In July, temperatures, explain. And this is going to vary since the sign will go from +1 to -1, so it'll vary by 14 degrees every 4 days. I don't know why that would happen. And this is varying by 10 degrees every 36 days. Or maybe, wait a minute here. 31, Walla Walla, which July has 31 days. T is the number of the day. So July 1st, we put in a 1. And when we get into 18, if we put in 0, this is 0, and sine of 0 is 0. So this would not play in it at day 1 or day 0. And this would not play into it. So it's going to be 73 on the 30th of June, 0 days. And then when you get to 18 days, this is pi, and this would be back at 0. And 18 divided by 2 is 9 pi. That's back to 0. And so these are not going to play into effect on the 9th. So this is saying every 4 days something happens. And this says every 36 days something happens. And I can't explain why that's happening. But the average, well, over this time, should be the area under this, the temperature integral of all this plus 73. It should be somewhere around 73 degrees average. Let's see what we get when we do the average. 31 days, so 1 over 31 is our period. Integral from 0 to 31 of 10 sine t pi over 18, if I haven't copied this incorrectly. Let's see if I can find that. This is 51. Make sure I can't. Oop. I did copy it wrong. Over 31. And this one is over 2. 31. I don't know where I got that other one. So the pi's cancel. That's 62. So varies 10 degrees every 62 times. 2 pi divided by pi over 31. Pi's cancel, that's 62. So it's going to go 62 days. It's going to vary 10 degrees. So it's going to drop 10 degrees over the month, probably is what they're saying. Or it's going to increase and then decrease. So if this is in July, the first 31 days, it's going to get 10 degrees hotter. And then the next 31 days for the 62 period, it's going to start cooling down. So it's going to increase 10 degrees in July by the end of July. And then the next 62 days, it's going to drop the 10 degrees. So August, it's going to go down the 10 degrees. So that's what this is doing, the monthly change. And this one is got a period of 4, and I think that should be, let's see, 2 pi divided by pi over 2. So that's a period of 4. Every 4 days it changes 14 degrees. Am I doing something backwards? Because I think it should be every half a day it changes 14 degrees. I think this is supposed to be from morning to evening change. But the overall is it goes up 10 degrees, so the average should be somewhere between 73 and 83, so the average should be about 78. Anyway, let's go ahead and do this. This is over 31 plus 14 sine t pi over 2. One more look at that. T pi over 2 plus 73 dt over the 31 t days. So we've got 1 over 31. That's 1 over b minus a, beginning of July to end of July minus beginning of July, 31 days. Integral of this, integral of sine, derivative of what is sine, that'd be negative cosine. We'd have the 10. So I'm going to put the negative out further here. We have 10. But we have to divide it by what we get the derivative of, which should be pi over 31 of t pi over 31 plus integral of sine, which could be negative cosine, negative, and we've got a 14, and we're going to have divide by pi over 2 sine t pi over 2. And then we're going to have an integral of 73, which would be plus 73t. Is that t the number? Maybe that's what I got wrong here. T is measured in days, and there are 31 days in July. Explain why you might see a pattern like this and compute the average temperature during the month of July. Okay. Evaluated from 0 to 31 days. Okay, let's see what happens here. 1 over 31. If we put 31 in here, we get 31 over 31, which is just pi. Cosine of pi is negative 1. So that'd be 10 over pi times 31. 31 times 10, negative 10 over pi. Plus, we put 31 in here. 31 divided by 2 is 31 halves. So 28 halves. Halves are, we're going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31. Sign is going to be negative 1 times negative 14 is plus 14 times the 2 over pi plus 73 times 31 minus, put 0 in. Cosine of 0 is 1, so we get 31 times negative 10 over pi. Oop, this should be cosine. Integral of sine is cosine, sorry. So 31 times we ended up there, cosine of there is 0. So this is 0. And 31 there is that. And then we got to put in 0. Cosine of 0 is 1, so we got same thing. And we got plus, put 0 in there, and that's 1 times 14 over 14 times 2, and that's a minus 14 times 2 over pi plus 0. So we have ugly, ugly, ugly. So minus 310 over pi minus a minus 310 over pi, they're going to cancel. And the 31 is going to cancel that 31, so I got 73 out of this, which we kind of figured that was kind of the baseline temperature. Then it increases by a little bit. And the amount is minus a minus, so it's plus 28 over pi divided by 31. And so we get a slight increase in the average. We get 28 divided by parenthesis 31 pi .287, so 73.287 degrees, and I think that's a little bit too small, but it says the average temperature is slightly higher than 73. Seems to me it should be a little bit higher than that, warming up into July. Negative, this would be, we're 31 days, minus 10, this over that, because the integral of sine is negative cosine. We have the 10, and we have to divide by the constant pi over 31. So that's 31 times negative 10 over pi. When we put 31 in here, we get pi. Cosine of pi is negative 1. Negative 1 times negative 10 is plus 10. Okay, maybe that's the issue. We put 31 over here, we get pi over 2 where cosine is 0, so this is gone. Put 31 in here, we get that. Put 0 into here. Cosine of 0 is 1, so we get negative 10. So negative is plus. And this is plus. That's what's wrong. 310 over pi plus 310 over pi. So that's 620. 620 over pi times 1 over 31. That's going to go in there 20 times. 20 divided by pi. 20 divided by pi is 6.3 degrees plus 0.28, so that's 6.5 onto there. So 6.5 onto there, 79.5 degrees approximately. That sounds more like it. Anyway, the idea is this is the fluctuating temperature long term because it's got a longer period. This is the short term fluctuation. It should be for day and night, and I don't know why I'm getting that. It seems like this should be 2 pi over that and change every 24 hours. But anyway, it's saying 4 days instead of every 1 day. This should have a period of 1, I think. So something's messed up there. But anyway, that's it. Here's the equation for the height. What's its average height over the first 2 to 6 seconds? So the average height would be the height, the integral of this function from 2 to 6 of 18t minus 9.8t squared dt. That's the area divided by the width, which is 1 over 2 to 6 is 4. And that would give us the average height. So that's 1/4 of 9t squared, and 9.8 divided by 3t to the third, evaluated from 2 to 6. Plug 6 in there, plug 2 in there, and take 1/4 of that, and that'll be your average height. Now it said find the average velocity. Well, the velocity is, this is distance, so the vertical velocity would be the derivative of this, which is 18 minus 9.8 times 2t. That's the velocity, dt, integrated from 2 to 6 times 1/4, the width of the, divided by the width of the interval. So then we would integrate this, and we'd get 18t minus 9.8t squared, evaluated from 2 to 6, and take 1/4 of that, and that would give us the average velocity. Average height, average velocity.